Okay, find the volume of the given solid bounded by the cylinders x squared plus y squared equals 16r squared and y squared plus z squared equals 16r squared. Alright, trying to visualize this at first was tough, but I realized that x squared plus y squared is just a circle, but what confused me was that the radius is not r. The radius is 4r. Oh my goodness, my pens are frozen. So the circle goes from negative 4r to positive 4r. Is that still on the... Okay. So, but it's a volume problem. So what's the z value? Well, the z value can be found through this cylinder. So it's like actually going on for like infinitely, I think, the two cylinders. But if you solve for z, you get z equals 16r squared minus y squared is the square root, so it's z squared equals the square root of 16r squared minus y squared, and that's what you're going to integrate. Okay, so I should really be sitting in a different angle. This is my first video like this. So 16r squared minus y squared, and then you're going to integrate from the values negative 4r to 4r. Doesn't matter if you do x or y, but for the first equation you have to solve for either x or y, and since there's a y in this equation, if you solve for y, then you'll have to use integration by parts, and it will be a really messy integral. But let's just see what happens if we use x. Then x equals, if you solve for that, you get the square root of 16r squared minus y squared, which is the same as that. But remember, you're going from the negative to the positive. So you go from the negative to the positive 16 r squared minus y squared. And then when you integrate that, you get, there's no x, so you just multiply by x. So when you multiply this by the top limit of integration, that's the same thing, so that eliminates the square root sign. So it's just 16r squared minus y squared, and then you subtract the negative, but after the negative it's also the same thing, 16r squared minus y squared. So it's just 2 times that value, and you can take the 2 out of the integral. I forgot earlier, since there are 2 cylinders and the way they come together, you need to multiply by 2, because we're not solving for we're solving for half right now. But now we're taking out another 2 because these are added together. So everything is multiplied by 2. So that simplifies the integral to 4 times the radius, negative 4r to 4r of 16r squared minus y squared. And I didn't mention earlier, this was dx dy. So now we have just dy. So you solve for that, and that's not too hard. 16 r, I feel like that should be an r cubed. Oh no, because once we plug in r squared times y minus y cubed over 3, and now we plug in a 4r, the negative 4r, and you get, my math is failing me. I usually use the calculator for these values, but I remember it's just 4 times 16 is 64 r cubed minus, what is 64 r, yeah, right, 4 cubed is 64 r cubed over 3, and then you plug in the negative 4, so it's minus a negative 64 r cubed plus 64 r cubed over 3. So since it's minus and negative, you just add them together. 128 r cubed, then it's negative 64 r cubed minus the positive 64 r cubed, so that's minus 128 r cubed over 3, and then you multiply that by 3, subtract the 128, and you get 256 r cubed over 3. And then, if you remember, there's a 4 that we never took out of the integrand, or that we need to multiply it by now, which will give you the final answer of 1024 r cubed over 3. Okay, that was a really bad explanation, but I'm trying to like explain things out loud for my personal study plan. So I might post this